So we're starting a new unit on proofs, which can be a little confusing sometimes about how we do these. So before we get into actually doing proofs, let's talk about some of the things we need to know. Now, we already know quite a few things. For example, here's my notebook, okay? This is what I take my notes in on a daily basis just to keep my idea of what's going on. And as I take my notes, at the back of it, I've got a thing of theorems. Tell you what, let's take a closer look at that. Okay, so this is my look at all my theorems. Switch over to cameras. And here, this is in the back of my notebook. You can see my vertical angles. All these that we talk about angles. And I highlighted the important words. And as we go on, there's more than that. Remember all the stuff we talked about, parallel lines? I started a lot of that. Now I left out alternate exterior, but they work the same way. Corresponding, same side interiors is supplementary. Some information about triangles we talked about. Isosceles, equilateral, equiangular, exterior angle theorem, largest angle, smallest side. So I'm trying to put all this stuff together so that I have it all in one place. And this one notebook is great. I use the back of the notebook so I can easily add to it as opposed to using the front of the notebook, which you can't add. So we need to add more theorems. And we're actually going to add a bunch that are very common to us, the theorems we've used before, because I'm going back to your algebra knowledge. So let's talk about the addition property. This is the same addition that you used in algebra. It said you could add the same thing to both sides. So if you had something like x minus 2 equals 5, you would go, oh, so I want to add 2 to both sides and make it x minus 2 plus 2 equals 5 plus 2. That's the addition property, adding the same thing to both sides. It doesn't mean adding this to get 7, okay? That's actually something different. The addition property says I can add equivalent values or things to both sides. Now, in geometry, we do it a little differently. Maybe I'll have if AB equals CD and EF equals HG, then what I can do is I can say then I can take AB plus EF, and that'll be CD plus HG, because I'm adding equivalent things to both sides. To A and B, I'm adding two things that are the same. That's how we tend to use this in geometry more. Not necessarily adding the same thing, although we do that sometimes too, but adding two things together that are two sets of equal things. That's addition. And it works the same way in subtraction. If AB equals CD and EF equals HG, then I could say AB minus EF equals CD minus HG. And that's subtracting equal things on both sides. So from this, I subtracted those equal things to get that. This works with every form of arithmetic we can do. Multiplication, same thing. If I've got two things that are equal, and another two things that are equal, that's a G, then I can multiply them together. Then AB times EF equals CD times HG. And remember, these double letters, those are like segments. That's the length of a segment, right? The length of segment AG. That's what we're talking about. Division works the same way. If AB equals CD and EF equals HG, then I could say AB over EF equals CD over HG. Okay? As long as these things aren't zero. Okay, remember you can't divide by 0. So those are very simple. They say we're able to do these things to both sides of an equation or put equal things on both sides, just like you did back in your algebra class. Then we get this reflexive property. Reflexive property is funny because it says something is equal to itself. It's like saying 5 equals 5. Well, no, we all know 5 equals 5. Sometimes in geometry, we might say something like AB equals AB, which is kind of obvious. Something is going to equal itself, but we need this step sometimes to sort of allow us to do some of these other things. You got to have this sometimes saying it so that it fits in here before I can add it to both sides or subtract it or divide it. So that's why we have to say that sometimes. Symmetric property, that allows me to write things in either order. Just like if you had x equals 3, then 3 equals x. You know that from algebra. Works the same in geometry. If AB equals CD, then CD also equals AB. And sometimes we just want to turn things around like that just to make it easier to see later on. That one really doesn't get used that much. Substitution, that's replacing something with something that it equals. So if I know that AB equals CD, and I also know AB equals EF as well. So AB is the same length as CD, and AB is the same length as EF. Then I could say that CD is equal to EF. Because what I'm doing is I'm saying in place of this, I'm putting what it equals. I'm putting that in place of it. That's substitution. It's very similar to the transitive property. But transitive property is just written a little differently. It says if AB equals CD and CD equals EF, then AB equals EF. And really the only difference between the two is the way the beginning stuff is written. Notice here, whatever you ended that equation with, you started that equation with. Here it doesn't matter. So these two often get used interchangeably, and that's not a big deal, okay? Let's take a look at how this stuff gets used. And like I said, we're sticking with some basic algebra stuff. So let's look at an algebra problem. I want to solve y plus 1 equals 5. Well, you know what to do here. If I've got y plus 1 equals 5, I want to subtract 1 on both sides. Ah, there it is. Subtract 1 on both sides. So what I want to do tells me I want to do subtraction. Which means subtract 1 on both sides. Now notice that's actually showing the subtraction, because the next thing I would do here is simplify, right? But we don't call it simplifying in geometry, because what I'm doing is I'm saying, well, 5 minus 1, that is 4. I can replace that with 4. And 1 minus 1 is 0, so I'm going to replace that with 0. When we replace things, that's substitution. And there it is. That's what we get. So that's the basic idea. You're just backing up every one of your moves with a geometry statement. Let's take a look at another set. This one's a little longer. So I'm going to work through it piece by piece here. I'm going to use my phone to sort of cover things up here. All right, so go Dale. When we look at this, 2p minus 30 equals negative 4p plus 6. So maybe the first thing I want to do is get the 4p over here. So I'm going to add 4p to both sides. Well, that tells me exactly what I'm going to do. I'm going to add to both sides. And when I do that, there we go. There's adding 4p to both sides. Now, generally in your algebra class, you'd want to simplify that. So negative 4p plus 4p is 0. 2p plus 4p is 6p. Simplifying, we're replacing. Instead of writing that expression, I'm going to write 0. When we replace, that's substitution. And when I do that, that gives me this statement. I replaced 2p plus 4p with 6p. Now what do I want to do next? Well, I want to move 30 over here. Moving 30 means I want to add 30 to both sides. So there we are. Addition property. When I add 30 to both sides, it looks like that. Now I want to say, okay, fix it, simplify it. Replace this with what it equals. Replace. Substitution. Replacing 6 plus 30 with 36, and that gives me this. So now the last thing I need to do is divide by 6. And there you go. Just told yourself what to do. Division property. When I divide, I get that statement where I'm actually showing division. And then, of course, we do the division, so we simplify. Oops. Running out of time. Okay, so that's the idea. We'll do more of this on Monday, and we'll talk about why we have to do this. Have yourselves a good weekend.